This is video 2 of erosion and deposition notes. You should have a hard copy set of notes to follow along with as we go through this PowerPoint slide. Directions for these notes is through the PowerPoints, you'll be given a definition, and I would like you to record the definition in the notes as you get it. So you're going to do that in this column right here. Then I want you to do your best to draw a picture or a sketch of the landform, and you're going to do that in this column right here. And then there will be an example in the PowerPoint, so I want you to include that or include an example of your own, and you're going to do that in this column here. And then the last thing is whether it was created by erosion or deposition. So as we go through, we'll discuss whether its primary creation was by erosion or deposition. So please follow along as we do the PowerPoint slide. So we're going to be looking at different landforms. Right now we're going to focus on the landforms that were created by streams. A stream is water. A stream is a channel of water. As water erodes soil and rock to make a channel, it creates a path that the stream follows. This channel can deepen and widen over time to form canyons and river valleys. So a stream or a channel can be something as small as a little gully of water after a hard rainstorm, or it can be as large as something giant like the Colorado River. I have two videos here to represent kind of an extreme stream or channel, and that is the Grand Canyon.
The surface of the earth has so many different...
So here your definition that you are going to write down is as follows. I would write down this section right through here as your definition. A picture, I would do your best to create something that looks like a stream or a canyon. The example that you can choose is the Grand Canyon, and then this is created by erosion. Erosion. So a channel right here, a path, a stream that flows created by eroded water. And then a canyon is a very large channel. So that covers kind of both of these together here. A channel would be any stream or river. Here is a second video. It's much older, but the information is very good in talking about how the Grand Canyon formed.
Scientists argue the details of precisely how and when the canyon was created. The mystery may never be completely solved because the river, like a master criminal, carried off the clues as it carved the canyon. Many geologists now think it happened something like this. All of the Earth's oceans and continents ride upon enormous pieces of the Earth's crust called plates, which fit together like a restless jigsaw puzzle, jostling each other at the edges. 80 million years ago, two of these plates collided at North America's west coast. The Pacific plate slid under the North American plate, creating the Rocky Mountains, and ultimately forcing the uplift of the whole Colorado Plateau. The combination of the mighty Colorado River flowing over the already rising plateau created a geological buzzsaw, a deep groove from which the river could not escape. Many scientists now think it took only about 4 million years for the Colorado River to carve the canyon. Compared to the rocks in its walls, some nearly 2 billion years old, the canyon itself is a relative youngster. But the river's buzzsaw can account for only a narrow gash in the earth. And in places, the rims of the Grand Canyon are 18 miles apart. How did the canyon get so wide?
It's important to understand that the river by itself did not carve this canyon. The river did cut down its own channel, but basically it's a transportation system. It's the freight train that carried all the rest of the rock out. And the canyon was widened out by all of the side streams and all the little rivulets that are carving into the canyon wall. It's not the river that made the great wide canyon that we see, but all the tributary drainage systems that led to the carving of the canyon.
Side streams and tributaries flow into the main Colorado River, gouging out their own side canyons, like this one. When there's a violent storm, truck-sized boulders tear loose from the canyon walls and are driven headlong in a terrifying wall of mud and rock called the debris flow. This rare footage of a debris flow sweeping through a dry valley was shot by scientists in China in 1990. Traveling 20 miles per hour, the flow packs the power of a river of liquid concrete. Here in the canyon, such debris flows rip out of side canyons, like this one, finally emptying into the main stem of the Colorado. Given enough time, all rocks, no matter how settled they may appear, are subject to change.
So continuing on with knowing about different landforms created by streams or channels, the next one we have is a floodplain. A floodplain is when a stream floods a layer of sediment is deposited over that flooded land. Many layers of deposited sediment can form a flat area called a floodplain. This area is often rich in nutrients, so these areas are very fertile. So you can see through here, the light green area represents the floodplain. This is the area that gets frequently flooded throughout the year. Here you can see during flood conditions. So I would add to your definition that this area is often very fertile, meaning that it grows crops and vegetation very well. An example of this is the Nile River in Egypt. I think you guys have studied ancient Egypt in history class, and right along the Nile River is where the populations were the greatest. It's where the farming is the greatest. It's where everybody thrives. When you go beyond the floodplain of the Nile River, you turn into the Sahara Desert for most of its length through Egypt. So floodplain, your definition is right up here. And then a picture, try to recreate one of these pictures to the best of your ability. An example would be the Nile River floodplain. You could also even use the Blanchard River floodplain in certain areas. And then it is created by deposition. Deposition. And make a note that these floodplains are often very fertile, rich in nutrients, and good for farming and plant material. The next landform we have is a meander and an oxbow lake. These are two different landforms, but they are related to one another. When a stream channel can run straight or curve, the curves that it creates are called meanders. So you can see here this curve in the stream as it starts to curve back and forth. Those are called the meanders. Sometimes those curves are cut off by some deposited material, and what is left behind is a crescent-shaped lake. And those crescent-shaped lakes are called oxbow lakes. So do your best to write down your definition here, draw a picture and label it. They are created by a little bit of erosion and deposition. We're going to get into these two videos for more of that information and examples. So here is a video to help explain how a meandering river is created.
Compared to the whitewater streams that tumble down mountainsides, the meandering rivers of the plains may seem tame and lazy, but not.
So to point out, these curves that you are seeing are your meanders.
Rivers of the plains may seem tame and lazy, but mountain streams are corralled by the steep-walled valleys they carve. Their courses are literally set in stone. Out on the open plains, those stony walls give way to soft soil, allowing rivers to shift their banks and set their own ever-changing courses to the sea, courses that almost never run straight. At least not for long, because all it takes to turn a straight stretch of river into a bendy one is a little disturbance and a lot of time. And in nature, there's plenty of both. Say, for example, that a muskrat burrows herself a den in one bank of a stream. Her tunnels make for a cozy home, but they also weaken the bank, which eventually begins to crumble and slump into the stream. Water rushes into the newly formed hollow, sweeping away loose dirt and making the hollow even hollower, which lets the water rush a little faster and sweep away a little more dirt, and so on and so on. As more of the stream's flow is diverted into the deepening hole on one bank and away from the other side of the
Take note that this is taking a while. These muskrats are aging. This is not something that happens in a day or two. It's something that happens over many years.
Channel, the flow there weakens and slows. And since slow-moving water can't carry the sand-sized particles that fast-moving water can, the dirt drops to the bottom and builds up to make the water there even shallower and slower, and then keeps accumulating until it becomes new land on the inside bank. Meanwhile, the fast-moving water near the outside bank sweeps out of the curve with enough momentum to carry it across the channel and slam it into the other side, where it starts to carve another curve, and then another, and then another, and then another. The wider the stream, the longer it takes the slingshotting current to reach the other side, and the greater the downstream distance to the next curve. In fact, measurements of meandering streams all over the world reveal a strikingly regular pattern. The length of one S-shaped meander tends to be about 6 times the width of the channel. So little tiny meandering streams tend to look just like miniature versions of their bigger relatives. As long as nothing gets in the way of a river's meandering, its curves will continue to grow curvier and curvier until they loop around and bumble into themselves. When that happens, the river's channel follows the straighter path downhill, leaving behind a crescent-shaped remnant called an oxbow lake, or a billabong.
So here you can see an example of an oxbow lake.
O un lago en herradura, ou un bras mort.
We have lots of names for these lakes, since they can occur pretty much anywhere liquid flows, or used to. Which brings up an interesting question. What do the Martians call them?
So hopefully you were able to gather from that video that the meanders are created by erosion and deposition. Erosion on the far side of the stream, but deposition on the inside of the loop. So you could draw that. When drawing your meandering stream, I would make sure that you note where the erosion deposition happens. So the erosion is happening on the far side because the water is moving faster here. And the deposition is happening on the inside of the curve because the water is moving slower there. So as you draw your meandering stream, something like this, you could do different arrows to represent slow versus fast. So on the inside, it's moving slow. And on the outside, it's moving fast. So these bigger arrows represent fast. Then slow, and then fast. And this is where your deposition is occurring, and this is where your erosion is occurring. All right, I have another video that's going to help to explain these meanders and how they form and what can sometimes cause them to stop forming and kind of be stuck in their place.
Hello, young people. Entrenched meander. This is the Yakima River just south of Ellensburg, Washington. Meanders are a feature of Ellensburg, Washington.
So you can use that for your example if you would like to. There are a lot of examples. You could even just use any river or stream that has twists and turns. The Blanchard River would work too.
Meanders are a feature of old age. These sweeping curves of the river. As rivers age, they develop more and more exaggerated meanders. We know this by flying over the Mississippi River system. And we see all stages of meander development back there. Eventually, the meander becomes so exaggerated that that curve is abandoned and an oxbow lake is formed, and the channel becomes straight again.
So the oxbow lake forms when the deposition happens with that meander. So if we go back to his picture, when the water is going to go by area of least resistance. So once this erodes 100% and the water has the ability to flow straight, it's going to make deposits here where the curve or meander was or is, and it's going to deposit enough material where this gets cut off and it becomes an oxbow lake.
Is abandoned and an oxbow lake is formed, and the channel becomes straight again. We can only develop these curves when an area is flat, like back east at the Mississippi. And here we've got these exaggerated curves as well, which means central Washington used to be flat. But there's a twist.
Meanders happen in flat areas when the river is near its end, closer to the mouth of where it's headed, or when a river is very old.
This place isn't flat anymore. This is a deep canyon system. So to understand that twist, how about we get up on that rim and get a big picture view of the Yakima River Canyon. Go up there.
You can see a little bit of erosion here by gravity. We will talk about these at a later date.
High up above the Yakima River, on the rim of the canyon looking down, is one of our meanders. We know about meanders. Meanders got established when the area was flat, a subtle curve becoming a more exaggerated curve. But then we froze the position of this meander and we entrenched it. Entrenched meanders tell us that the land is lifting against the river. The river wasn't up here and was cut down. We're sure that the river has been down there for millions of years, and the land has been lifting against the meander, against the river. The river's been cutting, matching an uplift rate of the bedrock, basalt layer after basalt layer, exposing themselves on the way up. The future of this meander is not more exaggerated meander. development of an oxbow lake. Instead, the future of this curve is more cutting because the uplift continues here in central Washington. Entrenched meanders just south of Ellensburg, Washington.
And that uplift is caused by plate tectonics and their movement, which we'll be talking about in a few weeks.